The goal of this video is to get you more practice with domain and range and also introduce you to the idea of in behavior. So let's start with number one. We're going to look at the domain and range first. And what I see is, I see the graph coming to the edge of where the axes stop. So, for example, here and here. So what we assume is that there's arrows on the end of this graph. Even though there's not arrows, we assume that this graph continues forever and ever in this direction, and also forever and ever in this direction. So what that means is, if we think about the domain, what's the furthest x value to the left that will lie on this line? Well, if it goes forever and ever this way, it's going further and further to the left. I know it's going down, but remember, domain just describes the x values. So the x value that's forever and ever to the left is negative infinity. So negative infinity is our lowest x value. Our highest x value, well, this graph goes forever and ever in this direction, which I know it's going up, but again, we're looking at the x values for a domain, means that this graph goes to positive infinity on the right. So our domain is all real numbers. Okay? Looking at the range, if this is going forever and ever down, that means it's going to approach negative infinity. So our lowest y value is negative infinity. Similarly, if we look at this graph, they're testing the bells, I'm sorry. If we look at the graph, it goes forever and ever in the up direction. So that means it's going to approach positive infinity. So again, our range is all real numbers. So in behavior looks at what happens to the y values as x approaches positive and negative infinity. So in English, that means we're going to look at the y values as you move to the right forever and ever, and you're going to look at what happens to the y values as you move to the left forever and ever. So in behavior, for every single problem, starts like this. It's written as, the word as, x approaches. We use an arrow for the word approaches. As x approaches infinity, we want to say, comma, y approaches, and then we're going to put what value y approaches as you move forever and ever to the right. Okay? Every single in behavior is going to start that way, so I could fill in this one already, even though we haven't even looked at that graph. So let's talk about it. As x approaches infinity, so as we go forever and ever to the right along this graph, what's happening to my y values? Well, we can see that they're growing. Where do they stop growing? They don't if they continue forever and ever along this pattern. So we would say that as x approaches infinity, y approaches infinity. Now we have to look at the other side. As x approaches negative infinity. So we can't move from left to right and have x approach negative infinity. We have to look at the graph going from right to left. So as we move to the left on this graph, what's happening to our y values? Well, they're decreasing. Where do they stop decreasing? They never stop decreasing. So that means that our y value is going to approach negative infinity. And that's our in behavior. So all in behavior tells us, it tells the reader what's going on in this picture. And where we want to get with this is, we want to be able to give you a description, give you a domain, range, in behavior, and have you come up with a picture. And we'll do that at the end of these notes. All right, now we want to look at example 2. And before we get into this example, let's add some arrows here. because without those arrows, we couldn't talk about end behavior. So, the domain and range on this one here, okay, let's think about this. The domain, what's the furthest it goes to the left? Well, since we have this arrow and it's going to continue forever and ever to the left, that means that our domain, and we're writing it in set notation, our domain, in the lowest x value is going to be negative infinity. Now, the point furthest to the right, it's going to continue forever and ever to the right, so it's going to go to positive infinity. That means that our right endpoint is positive infinity. So again, that's all real numbers, so we're asked to write it in set. You could write the words all real numbers, but since I did it in the previous problem, let's spice it up a bit and write it this way. So again, this reads the set of all x such that x exists in the real numbers, or x is an element of the real numbers. All right, now your range. Now, if you're not careful, you might think that the lowest y value is -2. But you have to realize that this arrow means that it's going to continue forever and ever in this direction. So, what that means is that negative infinity is your lowest y value, and since it goes up forever, it goes to positive infinity. That's all real numbers, so I'll write it this way. All right, now we can talk about the end behavior. So as x approaches infinity, so as you move to the right, as far as you can go, in the x direction, that's what this is saying, the first part, what's happening to y? Describe the y. The y is going up. As we move to the right, the y values are increasing. So that means y approaches infinity at the end of the graph. On the opposite end, as x approaches negative infinity, y approaches, so before I write it, let's think. As x goes to negative infinity, so as you go this way, as you go to the left, y is approaching negative infinity. All right. Number 3, let's again draw some arrows on here. It doesn't go to the edge of the graph, of the edge of the axes, I should say. So if without the arrows, we would assume that it stops here and here. So our domain, well, this goes forever and ever to the left. So that means that negative infinity is going to be as far left as we can go. And this graph is going to continue in this direction, so it's going to go forever and ever to the right. So our domain is all real numbers. Okay, our range, well, if we look at this graph, it doesn't get any lower than -2 because it's flat here. So this arrow tells us that this graph isn't at some point going to start going down again. Okay, it's going to continue and be this flat line forever and ever. So that means -2 is our lowest y value. So we're using interval notation. So I know it goes from -2 and the highest y value. If you're not careful, you might think 3 because that looks to be the highest value. But you got to remember, this is going to go forever and ever in this direction. So our highest y value is going to be infinity. We know we always use parentheses with the infinities. So now the question is, what do we use here? Well, the graph, let's take this point for example, -1, -2. Is that a point that exists on this graph? Yes, so that means that -2 is included. It's going to have a bracket. Okay, now let's do the end behavior. As x approaches infinity, y approaches. So as you move forever and ever to the right, so look at the right side of the graph. What's happening to our y values? They're increasing. They're rising. Those are all the same words. So as x approaches infinity, y approaches infinity. Now on the left, this is the more interesting one. As x approaches negative infinity, as you go forever and ever to the left, what value is y approaching? Well, y isn't approaching negative infinity here because it's not decreasing. It's staying the same value. So that means that y is approaching negative 2. All right, fourth example. We're using interval notation. The domain, so even though it looks like it's going straight down, it's not completely vertical, so that means it's going to continue to go a little bit to the left forever and ever. So it'll eventually get to negative infinity. Well, not exactly gets to that, but it'll approach negative infinity. And then on the right, it's going to get closer and closer to positive infinity. So our domain is going to be all real numbers. And our range, if we look, it starts at negative infinity because it's going to go down forever. So our lowest y value is going to be negative infinity. But the highest y value is not positive infinity because these are the highest points. So 10 is going to be our highest point. So our interval notation is going to be from negative infinity to 10. And we have a bracket on 10 because there's no open dot there. Okay, the end behavior as x approaches infinity. Now, let's assume this graph, they had a little something here and said f of x. So they're calling it a function of x. And they're using f as, this is like its name. Okay, this is another way to say y, by the way. When you're in an equation, you see f of x, that's another name for y, your outputs. So I'm going to use the function notation to write this. So as x approaches infinity, f of x, which is the same thing as y, approaches what? So as you go to the right on this graph, what is happening to y? Well, they're getting smaller and smaller or closer and closer to negative infinity. Okay? The other side of the end behavior, as x approaches negative infinity, f of x is approaching. So as you go further and further to the left, you're also approaching negative infinity. So that is domain, range, and end behavior. Now let's do the last two questions. So it says sketch a graph given the following information. So I'm going to set up a set of xy axes. Call this x. Call this y. So it has an x-intercept at 4, 0. So I'm going to call that there. And it also says as x approaches infinity, so on the right side, f of x approaches negative infinity. So as you move to the right, the y values are going to negative infinity, so it's going down. So over here, this is not part of the graph. I'm just telling you with this little arrow that it's on the right-hand side, it's going to be pointing down. Okay, and as x approaches negative infinity, that's the left side of the graph, f of x approaches positive infinity. So that means it's going to go up to the left. So what could a graph possibly look like? Well, it could just be a line like this. So we call that a negatively sloped line. Do we know exactly that's what it looks like? No, but with the information, this is a possible graph. You could also have something like, it could be a curve. Some type of curve like this. These two graphs would have the same end behavior. Okay, finally, let's look at this one. The x-intercept is at 4, 0 and negative 2, 0, so this one has two x-intercepts. So we'll say negative 2's here. 4 is here. And it says as x approaches infinity, so on the right-hand side, f of x approaches infinity. So it's going up on the right. And as x approaches negative infinity, f of x is approaching infinity. So as you move to the left, it's also going up. So a common graph that might come to mind is maybe a parabola. Okay, is that the only graph that it could be? No, it could look different, but this is one possibility. Okay, you might say, well, show me another possibility. What could that possibly look like? Well, let's do another one then. So maybe it comes here and it curves. With our information, this still matches the description. So that's another possible graph.